This is Chapter 4, Section 4, Day 1 video, and today we're going to use a table to graph a function rule. So a function rule is just an equation. So problem 1 says what is the graph of the function rule y equals negative 2x plus 1. So this is just a normal equation. You've probably seen them in the past. So I'm going to start with this table. Now notice how it has 3 columns, x, and then I rewrite the equation in the middle, and then y. So I get to choose what I plug in for x, and I'm always going to choose the same numbers. So I'm always going to choose negative 1, 0, 1, and 2. This gives me a negative, it gives me a 0, and it gives me a couple positives. They're all pretty easy to plug in as well. So next, I'm just going to replace the x in this equation with all of these numbers. So the first line is going to be negative 2 instead of x times negative 1. The second one, negative 2 times 0, negative 2 times 1, negative 2 times 2. Everything else in the equation stays the same. Negative 2 starts it, plus 1 ends it. Then I just need to solve. So negative 2 times negative 1 is positive 2. Positive 2 plus 1 is 3. So I just went ahead and solved all of these. Okay, so I got 3, 1, negative 1, negative 3. So these just give me x, y coordinates. The x number is here, the y number is here. So my first coordinate that I'll have to graph is negative 1, positive 3. The next one will be 0, positive 1. The next one, positive 1, negative 1. And the last one will be positive 2, negative 3. So then I go over to the graph, and I made my own x, y coordinates, or axes, and then I just graphed. Okay, so negative 1, positive 3, 0, positive 1, 1, negative 1, 2, negative 3. And then I connected them with a line. And that's my graph. Problem number 2 gets a little bit tricky because it's a real world problem, which means I'm probably not going to be able to do negative 1, 0, 1, and 2 because those don't always work for real world situations. So it says the function rule w equals 146c plus 30,000 represents the total weight, w, in pounds of a concrete mixer truck that carries c cubic feet of concrete. The capacity of the truck is about 200 cubic feet. What is a reasonable graph of the function rule? So I'm going to start with my table. So again, 3 columns. I'm going to put the equation in the middle here. So C, the equation, and then W. And now I need to find numbers that make sense for C. So I can start with 0 concrete. I can have 50, 150, or 200. Now, see how it says the capacity is 200? So I don't want to go past 200. So that's going to be my maximum, and my minimum is going to be 0 because you can't have negative amounts of concrete. So once I have those numbers selected, you could choose different ones like 0, 25, 50, 125. Any numbers will work here as long as they're between 0 and 200. Then you plug them in for C in the equation. So you'll have 146 times 0 plus 30,000, 146 times 50 plus 30,000, 146 times 150 plus 30,000, 146 times 200 plus 30,000. So once I have those plugged in, it's just a matter of solving. 146 times 0 is 0 plus 30,000 will give me 30,000. This next one I got 37,300. The next one I got 51,900, and the last one I got 59,200. So then I had to graph this. So I started with my x, which is actually the C. So this is the concrete. And then this would be the weight of the actual truck. So my concrete, I went by 25. So 25, 50, 75, 100, 125, because I had to get between 25 and 200. And the weight, I didn't even start until 30,000 because that was my bare minimum. And then I went by 2s to get all the way up. And it actually went a little bit off the graph, but that's okay. So I then graphed. So I had to graph 0, 30,000, 50, 37,300, 150, 51,900, and then 200 with 59,200. And when I graphed all those points on this graph, it became this linear equation. and that's my graph. So in the next vocabulary, first of all, I want you to make sure that the vocabulary words are typed out correctly. So this first one should be a continuous graph, and the second one should be what's called a discrete graph. So a continuous graph is a graph that's unbroken. That's why it's called continuous. So it can be a line as long as they're all connected. It can be a curve as long as it's all connected. There's no gaps. There aren't any weird things going on. A discrete graph is distinct and isolated points. So that means there are gaps. Now sometimes you'll have a graph that looks kind of like this. It goes for a little bit, and then it goes for a little bit. But see there how there's gaps in there? That is what we call a discrete graph. Anytime you have gaps in between, it's going to be a discrete graph.